All right, everybody. In the last video, we were talking about specific heat and how it's a physical characteristic that we can use to determine the identity of a substance, very similar to how we can figure out the identity of a substance by looking at its density. Okay, well, now I'm going to tell you and show you how to use a calorimeter in order to figure out what a substance is through its specific heat. Okay, a calorimeter is going to be when you have a container that is insulated. So this would be your styrofoam cup, and here would be your thermometer, and it has a known amount of water inside. And you put your new substance into it, the substance that you are looking to identify, and you're going to see how much it changes the temperature of the water. The way that the water would get hot is from the metal or the substance losing it. And this is what we actually do in class with our um, specific heat of a metal lab. Okay, remember we have the law of conservation of energy, which means that the energy of the water inside the calorimeter is going to reflect the energy that is lost by the metal that we are trying to use. So in lab, we would actually have a separate setup on a Bunsen burner where we put our metal in boiling water at 100 degrees Celsius, and then we would take it out and immediately put it into our calorimeter. And we would see that this hot metal would heat up the water inside our calorimeter. That water got hot because the metal lost that heat. And since we know that Q equals mc delta T, and the two Q's are equal to one another, the mc delta T of the water in the calorimeter is going to equal the Cm delta T of the metal. All right, so since we know the specific heat of water, we know how much mass of the water we have and the temperature change of the water, we can weigh the metal and we can calculate the change in temperature of the metal so that we ultimately can figure out what the specific heat and the identity of the metal is going to be. All right, so let's take a look at a sample problem for this. You will need a calculator, so please pause the video, go and get your calculator, come back, and you can work on these with me. All right, so here is a picture of our lovely calorimeter. All right, it has a styrofoam cup and it has a nice little amount of water that's going to be inside. So a calorimetry problem is actually going to be really, really wordy, but you have to realize that they are giving you two sets of data, one for the water in the calorimeter first, and then they are giving you the data for the metal. All right, so you have Q, M, C, and delta T. Q, M, C, and delta T. All right, so let's see what this says. In a calorimeter with 100 grams of water starting at 19 degrees Celsius, a 13-gram ring initially boiling in a hot water bath at 100 degrees Celsius is transferred to it and it rises to 19.59 degrees Celsius. What is the specific heat of the metal ring? Is it white gold? Is it silver? Or is it platinum? So what is this ring? So first of all, in the calorimeter, we have 100 grams of water. Okay, the water started at 19 degrees Celsius, and I have a 13-gram ring. Okay, and that started in a hot water bath at 100 degrees Celsius. And here's the big tricky part for some people. Okay, when you took that ring, here's our ring, you put it into the calorimeter. Okay, the water in the calorimeter rose up to 19.59 degrees Celsius, and the temperature that the ring started at 100 goes down to 19.59 degrees Celsius. So you're going to see this number in two places. Okay, we know that the specific heat of water is a constant, 4.184 joules per gram degrees Celsius. So first what we're going to do is we are going to solve for the Q of the water. We're going to do that first. And then we're going to plug that in to the Q of the metal and show that it was lost with a negative value, and ultimately solve for our real unknown, the specific heat of the metal. Okay, so I kind of identify all this over here for you a little bit more so you can see that. I would get a piece of scrap paper, all right, and maybe try to work this out with us. All right, so we are looking for the Q of the water in the calorimeter. We solve for this first, and this is what we solve for second, the metal unknown substance. We know that it is 100 grams of water in our calorimeter. Water has a specific heat of 4.184 joules per gram degrees Celsius, and it went from 19 degrees in my calorimeter to 19.59 degrees. So that gives me a delta T of positive 0.59 degrees Celsius. Okay, once I figure out my Q, so first I'm going to solve for the Q of water by using the MC delta T. I'm going to plug in 100 grams times 4.184 joules per gram degrees Celsius times 0.59 degrees Celsius. When I plug that in my calculator, grams and grams will cancel out, Celsius and Celsius will cancel out, and I'll get my Q value to be 246.9 joules. I do that first. That is this value right here. Okay, 246.9 joules. That is how much energy the water in the calorimeter absorbed. This is also how much energy the metal lost. So you'll see me use this negative sign here, 246.9 joules. Okay, the metal itself has a mass of 13 grams, that metal ring. We're looking for the specific heat of the metal, and the metal started off at 100 degrees Celsius and went down to the 19.59 degrees Celsius. So that gives me a negative delta T of 80.41 degrees Celsius. So what I'm going to be doing second is solving for C. Okay, I'm looking for the C of the metal. What's the specific heat of the metal? So C is negative 246.9 joules divided by, and remember, we have two things in the denominator, so we got to be careful. 13 grams times negative 80.41 degrees Celsius. Now notice we have a negative value here and a negative value here. A negative divided by a negative cancels out. Woohoo! So what I'm going to do is put this in my calculator by putting negative 246.9 divided by 13 times negative 80.41, close parentheses, or option 2, like we saw in the previous video, negative 246.9 divided by 13. Oops, go back here. And since there's two numbers in the denominator, divide by the second one also. Okay, what is our grand total answer? Our grand total answer is 0.236 joules per gram degrees Celsius. All right, that is our be-all, end-all answer. So, what substance is this? Look on the periodic table. Okay, if we look, silver is 0.235 joules per gram degrees Celsius. Gold is is 0.129 and platinum is 0.13. So what is this substance? This substance, that's right, is silver. It is a silver ring. They all are that silvery color, but you end up seeing that it proves that this is indeed silver. And this is one way that you can figure that out. So to review, what we did is first we figured out the Q of the water. All right, how much energy the water in the calorimeter is going to absorb. It was 246.9 degrees Celsius. We know the water went from 19 to 19.59, so it increased 0.59 degrees Celsius. Then I take this value and secondly use that to figure out, this is this value here, what the specific heat of the metal is. So since this is a negative value, we know that my delta T, because it is TF minus TI, is going to be a negative value also. And you see your negative 80.41. And this is in fact our silver. Be very, very careful how you plug this in your calculator. All right, make sure that you are dividing by both of those numbers or putting them in parentheses so you get the correct value. All right, so that is how you solve for a calorimetry problem.